Garett is a PhD student in the Department of Entomology in the College of Agriculture. His research interest lies in a passionate understanding surrounding sustainable solution for beekeepers. His current thesis work focuses on applying modern genetic tools to honeybee breeding. Applying genomic tools to beekeeping opens many additional opportunities for beekeepers because it allows them to improve their stocks and select for sustainable traits. His fun fact was that besides his deep passion for bees, he loves traveling, watching Minnesota professional sports, photography, and triathlon. The final title in our 3MT competition tonight is, "Why are so many honeybee males unable to reproduce?"
I remember the day I decided to become a honeybee researcher. It was November 2006, and I was working as a beekeeper. We were prepping our colonies for pollination, but when we got to them, nearly 80% of the colonies were dead. This added up to nearly 3,000 colonies. In this moment, it truly felt like beekeeping had changed forever, and in many ways, it did. Since that day in 2006, beekeepers lose on average 45% of their colonies every single year. The major cause of these colony losses is male infertility. In fact, 1 out of 10 honeybee males are unable to properly reproduce. If a queen mates with one of these infertile males, colonies will fail and die within 6 months, and this is quite short of the 3 to 4 years that beekeepers expect. And so in order to reduce these extremely high colony losses, we need to understand what is causing male infertility in honeybees so we can develop effective treatments for beekeepers across the entire United States. And so what is causing male infertility in honeybees? Male infertility is influenced by the DNA they inherit. Now, there's not a single gene that causes infertility. Rather, it's a combination of hundreds to thousands of these variants that increase a honeybee male's risk to being infertile. You can view these variances as tiny puzzle pieces. We have A, T, G, and C, and they make up the entire DNA sequence. If there's any differences in the puzzle pieces within these DNA sequences, that could potentially cause a honeybee male to be infertile. And so the goal of my thesis is to identify the specific puzzle pieces causing fertility issues in honeybees. So I compared colonies across the entire United States. I found some colonies were producing males with high quality sperm, while other colonies were producing males with low quality sperm. By comparing genetic differences between these colonies, I was able to identify specific puzzle pieces that were causing fertility issues in bees. Now, by identifying these puzzle pieces, we can now use these to help beekeepers more effectively breed and select for colonies that produce high-quality, high-fertile males, and overall reduce colony losses. My research not only helps beekeepers who continue to lose their businesses and their livelihood, but my research also has large implications for pollination. Due to these extremely high 45% annual losses, we face global shortages in pollination for many of the fruits, vegetables, and nuts that we consume every single day. Without bees, we would face extreme shortages in apples, oranges, almonds, and this is just to name a few. So by helping beekeepers improve honeybee male fertility, we can not only support pollination, but reduce colony losses. And maybe I can finally prevent beekeepers from feeling helpless and defeated, just like I did in 2006.